Today we're going to talk about energy in the atmosphere. So how are energy and temperature related? That's a good question. Well, particles in motion have energy. So anything in motion is actually exhibiting energy. The more energy, the more they move, the hotter they are. Okay? So when you are boiling water on the stove, there's lots of energy, lots of motion, and you see that through the form of what? Bubbles. Okay, so temperature is the measure of the average kinetic energy of particles. Kinetic energy is moving energy, it's in motion. The more the particles move, the more they expand. Thus, they will increase volume of whatever object you're talking about, which is known as thermal expansion. So, example, at 70 degrees, this is what the water in the glass case looks like. At 140 degrees, you can see that it has slowly started to expand. The amount of water has not actually changed. It's just changed its shape. It's expanded. At 180 degrees, it's completely full of the container, causing the container to bulge, thus allowing it to want to escape. All of this exhibits the term thermal expansion. So what is heat? Heat is the thermal energy that is transferred between any two objects. Could be more than two, but we're always talking about two. Energy will transfer until both objects become the same temperature. Example, object A is hot, object B is cold. Object A slowly starts to transfer energy in the form of heat to object B. Thus, eventually A and B will be the same temperature. So this happens when you're cooking something on the stove. So you put a pot of water on to boil. The pot, the water, and the burner are all different temperatures. When the burner has transferred enough heat to the metal pot, the pot will get hot, and thus it will be the same temperature as the actual burner itself. So there are three major forms of energy transfer. The first one is radiation. And radiation is the transfer of energy as electromagnetic radiation. So basically, you feel heat without direct contact of any object. Solar radiation is a great example, and it's very important or vital for life on Earth. So some examples of radiation in these pictures. You feel the heat from the lamp, but you don't actually touch it. Here, you feel the heat from the sun, but you're not physically touching the sun. Another great example, you feel the stove's heat, but you don't touch it. Okay? Anytime you feel the hair dryer's heat on your face as you blow dry your hair, but you're not touching the heat source itself. That's radiation. Convection is the transfer of energy due to motion or movement of matter. And generally it goes in the form of a convection current. So the movement of matter is going to be due to differences in density. Hot or less dense matter rises. Cold, more dense matter sinks. So essentially hot air rises, cold air sinks. Hot air rises, cold air sinks. Also true when you're cooking on the stove. You put the water on, the water's cool. As you slowly have it start to heat up, okay, the water starts to do what? It bubbles. All of those bubbles are showing you that the hot water is now coming to the surface. Those bubbles are hot, whereas the cooler water is at the bottom, and it creates a cycle. So there are three places on Earth basically that you will see convection currents, and it always moves the same. Hot rises, cool sinks. In the air, hot air will rise and cool air will sink, creating breezes. In the ocean, hot water will rise, cool water will sink, and that creates deep currents. And then in the mantle, the hot rock will rise, the cool rock will sink, and this creates essentially the motion of the plates. Conduction is the transfer of energy from one object to another, but both objects are touching. Thermal energy of particles move directly from one object to another that they physically touch and come in contact with. So, going back to my metal pot, if you're cooking on the stove, you touch the pan or the boiler, you come in contact, you get burned. That is conduction, direct contact. You are curling your hair and you accidentally burn your skin because you touch the curling iron to your face. Conduction. So how do they work on the surface together? Well, they basically work together to heat up our troposphere. The sun heats up the surface of the earth through solar radiation. The conduction is the heated air. Conduction is when you touch the Earth's surface. You physically come in contact with it. So if I am standing on the surface with my bare feet, that's the conduction. I feel the heat from the ground to my feet. I feel the radiation from the sun just heating my body. And the convection is that the heat is transferred up to the layers of the air. Because we know the hot air rises and the cool air sinks. So it will be cooler here than it would be here in a certain given area. So let's see if you can figure out some examples. Which type of heat transfer? Your feet get hot when walking barefoot across hot pavement. So your feet are physically touching. You can feel the heat from the hot iron without touching it. That's number 2. So you're not touching it for number 2. Number 3, in winter, the second floor of your house is warmer than the first. That's that hot air rising. Number 4, you are lying on the beach and the sun makes your skin tingle. It's that feeling, but you're not touching it. And number 5, you burn your finger when you accidentally touch the hot stove. So let's see if you got them right. Whoops. Your feet get hot when walking barefoot across hot pavement. That would be conduction. You can feel the heat from the hot iron without touching it. Radiation. In winter, the second floor of your house is warmer than the first. Convection. You are lying on the beach and the sun makes your skin tingle. Radiation. And the last one, you burn your finger when you accidentally touch the stove. Conduction.